This is an example of Venn diagrams and sample space. And in this problem, we're looking at 60 people that were surveyed and asked which genre of TV show they prefer. And it breaks it down. And so because there's three categories, there's action, drama, and comedy, I've drawn a Venn diagram with these three categories and the intersections of all three as well as each one. So I'm going to work backwards, and I'm going to start in the very center of the Venn diagram and work my way out to find the numbers for each part of the Venn diagram just based on the information I'm given. So the first thing you'll notice is that I know that there's three people who like all three genres. So in the very center of this entire thing, the overlap of comedy, action, and drama are those three people. Next, I'm going to use this information about the 5, the 12, and the 9. So I know that there's 5 that like comedy and action. So comedy and action, the overlap there is 5. And the overlap of these two sections, because of that, there has to be 5 total in this overlap. So 5 minus 3 is 2. So there's 2 that like only comedy and action. So of the 5 that like comedy, action, drama, only 2 of them like just comedy and action. So the next thing is there are 12 that like both action and drama. So same thing, I'm going to look at action and drama. And in this intersection, there should be 12. So the leftover part would be 12 minus 3, which is 9. So 9 people like just drama and action. The next thing I'll know is that there's 9 who like only comedy. So in the comedy part that is not overlapped with anything else, there's just 9 people. From here, I can take the totals to find the rest. So in total, there are 34 people that like comedy, which means in this entire circle of comedy, there should be a total of 34. So if I take 34 and I subtract the 3 sections that are either by themselves completely or overlapping, so 34 minus 9 minus 3 minus 2, I will get 20 left. If I take the same thing for action, and I know that there are 22 who like action, I take 22 total in this circle, subtract off the 9, the 3, and the 2, I will be left with 8 who like just action. And then for drama, same thing. The total for drama is 36. I know the 20, the 3, and the 9. The whole thing has to be 36. So 36 minus 20, minus 3, and minus 9 leaves you with 4 who like only drama. Now, is this everyone? We need to check. So if we add up the totals of all of these, it should equal 60. If it does not, that means there were some people who surveyed did not like drama, comedy, or action. So they may have liked a different genre, maybe romance, but it's not included here. So they would still be included in the survey, but they would be on the outside of the circles, but still within the rectangle of the survey. So when I add up 9 plus 20 plus 4 plus 9 plus 3 plus 2 plus 8, that is a grand total of 55, but there were 60 surveyed, which means there were 5 who did not like any of those 3 genres. Now to do probability problems with this type of Venn diagram, this is my sample space with all my choices. So the first probability question is, what's the probability of randomly selecting a person who likes exactly one genre? So that would be all these people on the outside that are in the circles, but they aren't in any of the overlaps. So 9 plus 8 plus 4 over a total of 60 is the probability for those who like exactly one. So 9 plus 8 plus 4 is 21. 21 out of 60 people, 35% of people surveyed like exactly one genre. Last question, what's the probability of randomly selecting a person who likes exactly 2 genres? So that would be the overlaps of the action drama, the action comedy, and the comedy drama. So that is this 20, this 2, and this 9. Those are people who like exactly 2. So 20 plus 9 plus 2 gives you a total of 31 out of 60, which is 51.7% of people. So just over half the people surveyed like at exactly 2 genres. And from here, you could solve other probability problems to find the probability of exactly 3, which would be 3 out of 60, and so on. So this is how you solve Venn diagrams and probability.